Hey guys, this is our second video of the week, and today we're going to cover an introduction of database organization and a little bit more about client-server interaction with databases. One thing to note, today we're not going to be going over anything within our database itself. We're going to be going over some stuff in Excel just to cover the core concepts of what we're going to start doing next week, which is our CRUD operations, or create, read, update, delete, within our database itself. So this should be a fairly quick video. Like I said in the last video, a database is not a standalone server, right? A database is something that is running on a pre-built server. It's just another piece of software. This piece of software allows incoming connections on a specified port to access the data located within it. So a couple ways that we can interact with databases are through, like I said, database clients, something like SQL Server Management Studio or MySQL Workbench or other things like that. Another way to do that is through a fat client application such as, say, iMessage, or what's a Windows example? Such as iMessage, or maybe a game you're playing on your Windows machine. And the way this is orchestrated is a setup similar to what we're looking at here. And I'll go ahead and zoom in on this. But basically, what we have is we have a client which is showing the user a user interface, whether that be through a TUI or an actual graphical user interface. And so this client sends a request through the underlying code to a database. Now, in the diagram here, we're saying client, application server, database server, which is another form as well. So there's a couple ways we can do this. Our client itself can connect directly to the database, or we can have a client, which is an interface, that's hitting a business logic controlled application server that is then connecting to a database. So a good way to think about this is in the case of things like web applications, right? So a web application will render, let's take maybe a Node.js application. So your browser will render the UI components to show you what you need to see, right? So that's what's showing in your browser. That's your quote-unquote user interface client. Now, when you want data, that client is going to interact with the application server that's going to be executing our underlying CRUD statements, or underlying business logic, which is still executing CRUD statements, to pull data or update data or delete data from our database. Now, we also have, like I said, database clients that interact directly with the database, or we can have an application server that has no client that's just running in the background, maybe harvesting data down from, say, harvesting data from Amazon Web Services about your environment and dumping that into our database, or maybe it's strictly reading and sending a report to a specified user or a specified email address. Now, the other side of this, and this is what I started to mention a minute ago, is a web-based system, right? And so this is what I was talking about with our Node.js example. We have our client, which is a web browser that is sending a request through the internet to a web server, which is running application code, which is then interacting with our database. Now, in the case of the web system, there's not really a way around this, as there is with a database client or maybe an application running locally on your machine that's maybe using your local database. when we're dealing with web-based systems, we're pretty much always going to have a client, whether that be your web browser or when you get into the more advanced topics, an application running on your machine that's sending a request to the internet to another web server that is then interacting with that database. So that's web and fat client database applications and interactions. So pretty straightforward. Obviously, there's a lot of ways to connect to a database. These are the most common. But we're not really too worried about how we connect to the database. We know we use a client. We know that the data is stored there. So the real question is, what about the data itself, and how is that data organized? So I bring you to Excel, which is how we're going to take a look at this. So in a relational database model, data is organized in what we call tables inside of a schema. And you can think of a schema as an Excel workbook, right? And inside of a workbook, you can have multiple sheets. These sheets can correspond to tables. Now, that's not how I've organized the data to show you guys, but we can think of schemas and tables as Excel workbooks and then sheets within that workbook. Now, inside of an individual sheet, we have rows and columns. Well, inside of a database table, we also have rows and columns. And these columns store our individual rows of data or individual cells of data, or fields and records. So a field would be one of our columns, and a record would be a value stored in that column. Now, the way this is broken down is we have a series of columns, and these columns in Excel, we don't have to specify, well, we can specify data type in Excel. We can add conditions to it and require only a certain type of input into that field or into that column. The same thing happens in a database, right? So we have ID. ID, if we want it to always be an integer, we specify that that column in the database is going to be an integer field. With make, if we only want make to be a string, we will specify a varchar or char data type as our column type or as our field type. Same thing with models, same thing with year, same thing with color. Well, year, we could do several different things. We could set a date type field, or we could set an integer field, or we could specify just a varchar if we didn't know the field or know the year. The other thing that we can do is we can set default values inside of our columns, right? So inside of ID, or let's create a new record. We'll say Chevy, and then say we don't know the model. We can specify a default value to be NA, or we can specify the year to be NA, and then a color to be blue. Now, one thing to note is that we can also have a field that auto increments, right? And this only works in integer fields. And what we mean when we say auto increment is that every record we make, we are incrementing our value by one or a specified value, right? So let's say that our ID field is auto incrementing. Now we have, for each record, as we add new records, I can't think of a focus. 5 gold. So for each record that we add, we're now auto-incrementing or increasing the value stored at ID by 1. Now you might be wondering, so why would we want to increase the value stored at ID by 1? Well, the reason for this is for creating what we call an identity column, or in some cases or it's also can be called a primary key. These are two separate things, and I'm going to tie them back together in a second. So what an identity column is, and it can be a primary key or it cannot be a primary key, is a unique identifier that's auto-incrementing, right? So for each car that we have listed, we have an identity column that is saying, okay, Ford Mustang has ID 1, Toyota Tacoma is ID 2, Honda Civic is ID 3. Now, this doesn't have to be our primary key, but typically we will see identity columns being primary keys. And what a primary key is a unique identifier specific to that row. Now, I know that sounds very similar to identity key. However, there are instances where our primary key will not be an integer, but rather maybe a string, or maybe an integer specific to maybe an integer that we have already defined specific to a make, model, year, and color of a vehicle, right? So let's say that these are vehicles that have already been sold. Well, all of these vehicles are going to have what's known as a VIN, or a vehicle identification number. I'm assuming everybody knows what a VIN is, but stranger things have happened. So what we could have is we could have ID being the VIN of that vehicle, or let's rename that and call it VIN. We could have VIN as our primary key, and then we could have an additional column that is an identity column for our vehicles, but is not our primary key, right? So our ID column can be auto-incrementing, but our primary key can be something unique, such as a VIN. But generally, it makes more sense to have an ID being, generally speaking, it makes more sense to have a primary key also being an identity key. Now, what we could do is we can have what's known as a composite key, which is a culmination of two unique values inside of our table, right? So a composite key would be composed of ID and then VIN. And there are situations that call for that. I haven't seen very many of them, but there are situations that call for that. But that to be said, so we have these primary keys, identity keys, or let's change this. So we have primary keys that uniquely identify a record in our database. Now, why would we need, or what would we use primary keys for, right? Because, all right, in this particular data set, I can say, oh, well, the way the data is organized, there's only going to be one 2009 Ford Mustang, or there might be one 2009 Ford Mustang that's black, right? Because I have no other identifiers. So I can assume that, basically I can assume that all of my records are going to be unique, or relatively unique. But what if I wanted to correlate that data to another data set, right? So maybe who owns that data set. And that's where we get into table relationships, and that's really where we start seeing the value of primary keys and what are known as foreign keys. So if we look at sheet 2 here, sheet 2 has poorly organized two tables. Now I know I said earlier that we can look at schemas and tables as worksheets or workbooks and sheets in Excel. Well, I haven't organized it like this just to orchestrate some points. So in table 1, we have, or in our cars table, we have the same data that we had before, which is our ID, our make, our model, our year, and our color. In table 2, which is our owner's table, we have the ID of an owner, which is an identity primary key. We have the owner name, the address, the loan status, and then the vehicle ID. And you'll notice that the vehicle ID corresponds to the primary key of our vehicles table. And when we get into our actual database, we can start specifying these relationships to require that vehicle ID always matches a value stored in our vehicles table. And this vehicle ID is what's known as a foreign key, right? And so a foreign key is a primary key that's stored in another table that maps to data in another table, right? So in owners, we have vehicle ID 3 corresponds to ID 3 in our cars table, right? So we can identify now that John Doe, living at 123 Elm Avenue, has an open loan on a 1998 Honda Civic that is silver. And when we get in, and I'll get into the sequel about pulling this data back next week, but really we just need to know that these relationships can exist and that these relationships may be unique or they may not be unique, right? So let's add another user and we'll say, I don't know, so now we've added a new user, Jack Flash, that has a new unique primary key that is auto-incrementing, or we can call that an identity key or an identity field, that also owns a 2016 black Ford Mustang, the same as Jim Smith. Now, what's happened here is we've created a type of relationship known as a one-to-many relationship. And a one-to-many relationship basically means that many owners can have 2016 black Ford Mustangs. Now, we could also have a one-to-many relationship, and we can do that through the use of what are known as constraints. And what a constraint does is basically says, based upon these conditions, only allow this type of data to be put in. And so we can have a one-to-one relationship from our owners to our vehicles and require that each owner maps to a specific vehicle here. And this is where we would be using something like a VIN, or, well, in theory, we would use something like a VIN to uniquely map each vehicle, or uniquely identify each vehicle in the table, right? So we could have 30 black Ford Mustangs, but each one would have a unique VIN, but maybe we want our ID to correlate to the make, model, year, and color of a vehicle. But then we want a unique identifier for that specific vehicle. So that's where our VIN would come into play. So that's a one-to-one relationship. And as I said before, a one-to-many relationship is a relationship in which many owners, or in which one car can be mapped to many owners. And so, like I said, we can have many owners having a 2016 black Ford Mustang, or we can have many owners having a 1998 silver Honda Civic. So that's a one-to-many relationship. Now, the last type of relationship that I want to go over is going to be our, well, what's known as a many-to-many relationship, right? And this is usually done through a tertiary table, such as this table here in the center, right? And so what a many-to-many relationship says is that in the context of our tables here is that many cars can have many transmission styles, right? Because most cars that come out of the factory have multiple transmission styles, right? So some Mustangs have manual transmissions, some Mustangs have automatic transmissions. Some Tacomas have manual, some Tacomas have automatic transmissions. And so what we've done in a many-to-many, what happens in a many-to-many relationship is that we have these situations or these records that indicate, okay, vehicle 1 has transmission ID 2, or has a transmission ID of 2 and a transmission ID of 1. So that when we do our sequel, we can identify, okay, vehicle 1 has, out of the factory, both automatic and manual transmissions. It's the same thing with vehicle 2 and vehicle 3. Vehicle 4 only comes with an automatic transmission. So there will be times where, like in the case of vehicle 4, you don't necessarily need the many-to-many relationship, but because your other fields do need it, you add a record in our tertiary table. Now, as far as pulling this data back, we will get into that next week. Hopefully this explained a little bit more about how our data is organized and how our schemas or databases, you'll see them called schemas and databases. I prefer the word schema because I feel like it is a more unique way to identify a database within a database, within a database application, right? So a database application can have multiple databases inside of it. Well, wouldn't it be easier to call them schemas, right? So I can say that my MySQL database, which is a database server, has multiple schemas inside of it, right? And then we have tables, which are obviously self-explanatory. So I hope that explains a little bit about what we're going to do, and I'm sure that this might be confusing for some of you at first. I'm hoping that when we get into actually creating tables next week and executing our CRUD operations on this data, we'll start to make a little bit more sense about the data and how it's organized and how to retrieve it.